Hi, welcome to the final build video for the Blue Eagle Labs all-metal Delta. In this video, we're going to be installing the Z probe, flashing the firmware, testing all the electronics, putting on the build plate, calibrating the height, and getting it all ready for your first print. All right, next it's time to install the Z probe. This goes onto the hot end and it's used in the auto calibration process. So what we're going to need is an end stop switch and a cable and the two M2.5 screws and nuts. You're going to solder this together to the wire like the other end stop switches that we did earlier. I already have it done, so I'm not going to show you, but you can watch the other video if you have questions. Basically, the orientation doesn't matter because this is just on or off switch, but you want to use the outside terminals here. Next, you're going to be mounting the end stop switch to the little plastic Z probe plate, just like so, with the M2.5 screws and nuts. All right, this gets mounted onto the hot end, and to do this you're going to have to remove the rubber boot if you have one, and we're going to need to back out the screw that holds in the heating element right here. Be really careful with this hot end, especially the element and the fragile wires that come out of the other side. Try not to bend them at all. In fact, like, if you can unscrew that screw without messing with the element and having it move around and pop out, all the better. I'm going to take that screw out, and this little assembly is going to fit over the hot end, and then the screw is going to go where this slot is. You may not have to take yours out the whole way. Yeah, like so, I guess. You don't need to take it out the whole way. And slide it in and then tighten it down. You want to tighten it so it's not going to flop around, but you'll notice as you tighten up that screw, the bottom pinches to pinch onto the heating element, and it causes the probe to rock a little bit, which is fine. Just make sure it's on there firm and it's not going to wiggle around when the auto calibration routine's doing its thing. I'm going to take the cable, just going to run it up out of the way so it doesn't get caught on anything. And then this gets plugged in to where the end stop switches are. This one's labeled Z-. It's going to be using the same two pins as the other two switches. It's a 2-pin socket and a 3-pin jack. And it doesn't matter the orientation, again. All right, now that we have the Z probe installed, it's time to flash the firmware and load it onto the SmoothieWare board. You're going to need a SD card and preferably a Windows machine. You may have issues formatting the SD card on a Mac computer. Insert your SD card, and when it appears, reformat the drive as FAT. All right. Once the drive is done formatting, you can drop and drag the firmware.bin and config files to your SD card. You can find the firmware and the config files at the Blue Eagle Labs website. I'm just going to check they're there. Great. Now you can safely eject your drive. And we're going to take the SD card and put it into the card reader, or the card slot on the SmoothieWare board. Now that that's installed, I can power up the machine. Take note, you may want to install an AC switch on this printer. It doesn't have one built in, and especially for this test, it may be useful. Since we don't have one, I'm going to be using a power strip here with a manual override switch, so I can cut the AC power like at any moment if I run into problems with the motors just kind of driving off and damaging themselves. So when I first power on the machine, it's going to unload the config file and the firmware.bin, load everything up, and if we connect the SmoothieWare board to your PC, it should appear as a new drive. And here we are, all metal Delta. I'm going to click on that. And you can see it unpacked the firmware.bin file into just a cursor file. So that means that the loading of the firmware was successful. And while it's on here, I'm going to take this other calibration calibration 230.g code file. We're going to use that later. What's neat about this machine is you can just drag and drop files to the machine, to the SD card directly that's running the firmware. So we're going to load a model on there to test later, and that's good. All right, now that our firmware is successfully loaded on the SmoothieWare board, it's time to connect and test out the electronics. You're going to need to download Pronterface from either the Blue Eagle Labs package or the pronterface.org website. Pronterface allows you to control all the functions of the printer manually. So first we need to connect. It's going to be one of either two COM ports, and the baud rate should be 115/200. Once connected, the first thing you want to do is check the end stop switches. Before we do any motors, we want to make sure these are connected first. So if we home, we know it's first that it's working, and then it's also like triggering the right switch for the motor. So we're going to go down here, and at this little box at the bottom of the screen, you can manually enter G code. And so for this one, we're going to do an M119. We're going to do an M119 command and send it. And that gives you feedback of all the sensor positions. So I'm going to, go around. We'll repeat this once for each switch. Send it again. So I checked holding down the X column. The X went from 1 to 0, or 0 to 1. So that one's working. And we'll try it again for the Y. And there we have Y working. And I will do it for Z. Z works. Now, and then lastly, I'm going to try it for the Z probe. So 0 means not triggered, 1 means triggered. So the Z works. You can also see that my probe, the wire had become disconnected, so that was shorted and was triggering as a connection. So I'll try it again. There we go. I'm not holding any switches down. They should all be 0. untriggered, and I will trigger the Z probe to test it. There we go. So all the end stop switches work. Great. Now what I'm going to do is we'll test the motors with this home key right here. You know, have your finger on standby in case there's any sort of like disaster when you hit and fire up the motors. But if all goes well, the carriages should rise up, and you know, it'll trigger the end stop switch, which we know works, and then it'll stop the motor at the 0 home position. So here we go. Great, perfect. We know all 3 motors are working and everything's connected. I want to also, you can try to manually drive around the printer using these features. Be careful, the 10mm steps, it can move like pretty fast, so you want to make sure it's not going to crash into the bed. So for this, maybe you want to do this on the last step too. I'm going to put down some kind of cardboard or a piece of plywood, just something to protect the board, the SmoothieWare board, in case your motors are installed reverse and they crash down in. So I'm going to manually lower the Z-axis, which is all 3 motors, 1 millimeter at a time, centimeter. Great, that seems to be working. And then I'll try go back and forth on the X-axis, which should be this way. Next, I'm going to try out the Y-axis. So the plus Y should move it back, and the negative Y should move it forward towards the screen. And it looks like everything's working. I'll go back and home it just to get it out of the way. All right, now we're gonna test the extruder. You see, we only have 1 extruder on here, but the routine's the same for 2. I think you can set up a dual extruder button on printer face. We also have filament in the machine, which is probably not ideal, but we just have ours engaged a little bit. So I wouldn't insert any in until you know the extruder is rotating the proper direction and everything's working. Okay, I'm going to hit the extrude button and check it, make sure the direction. So the hobbed gear should be rotating toward the feed tube, you know, pulling down material. It looks good. There's also a reverse button on printer face, you can test that out. There we go, it's reversing. So it looks like everything's good with the motors on this machine. I think we're ready to put on the hotbed. All right, now that the motors are all tested and working properly, we're going to be installing and testing the hotbed. So I'm going to be using this Gecko Tech board, and it goes on top of the build tray just like this. But it needs to be wired into both AC power, which we should have prepared already, and we need to plug in the thermistor that measures the temperature. So before I really bolt it down, I want to wire it up, and then I can test the, using printer face, I can test that the board heats up and everything's working properly. But this is AC power, so make sure you disconnect all the power, the plugs and the cables and stuff before messing around with this. So there's the 2 wires that we wired up previously for this thing. They're getting connected to the AC terminal on the solid state relay. Next, then I'm plugging the thermistor into the jack on the SmoothieWare board. It is TH1 is the name of the jack on that. And we're about ready to go. I'm going to try to tuck the wires in here a little as tidy as possible, and then attach the AC cable to the power supply. Yeah, like that. And we're just gonna just rest the board on top here for the time being, and then plug it in and power it on. And then you're gonna need to reconnect the prana face. Okay, once you get prana face connected, go and turn the heated bed on and set the temperature for like 60 or 110, it doesn't matter, and then we'll go to set. This little graphic here shows you the temperatures for the bed and the hot end, and we can see the bed it's rising, so we know it's working. Great, yeah, I feel it heating up. It seems to be working. And the thermistor is working, it's reading the temperature. All right, so I just tested the bed and that's heating up, so I know that's working. Now we can test the hot end. Be careful if you've already installed the Z probe, as that's made of plastic, and if you just turn on the hot end to the default filament temperatures, it may melt and deform it. So what we're gonna do, you can actually type in custom settings here. It has 185, 230 for ABS. I'm just gonna put in a low number, like 80 or 60 degrees Celsius. And I'm gonna set that, and you don't even really need to it heats up really fast, and you can just watch the graphic here to make sure your thermistor and your heating element are working. And yeah, it's already almost up at the target. So that's working, and I'm gonna turn this off really quick so it'll melt the Z probe. So great, so it seems like everything's working. Next step is where we're gonna actually finally mount the hotbed to the machine and seal off the electronics. So if there's anything if you wanna like tie down wires and organize anything, pretty much anything you want to do to the SmoothieWare board and the build tray, I would do now, because it's going to be a lot more difficult after the build plate's attached. All right, next we're going to mount the build plate. For this, we're going to need the springs, the M2.5 by 25 millimeter screws, M3 washers, build plate, and the M2.5 screws. I'm going to start off by cutting the springs somewhere between 1/2 and 3/4, about there. I'm just using kind of a heavier pair of wire cutters to do this. And repeat this for the other 3 springs. So I have that ready. The way this goes together is the M2.5 screw goes through the build plate, then a spring, then a washer, and then the nut underneath. This is really kind of difficult because you both need to, like surgically fish the nut in there and hold it with a pair of needle nose pliers or forceps or something, while simultaneously squeezing down and compressing the spring enough that the screw is sticking out. So I'm gonna use a pair of I'm gonna use a clamp like this just to help me out. Be careful you're not like crushing anything important. All right, you just want to get the nut on there a few turns to keep it locked in place. We'll tighten everything up and level it after all three of them are on there. All right. Now that the springs are on and the build plate's mounted, I'm going to check that everything is square and adjust the 3 screws to make it so. That's perfect. Pretty good. That needs to be loosened. As you adjust one, it kind of throws off the other one, so you may need to work around a few times to really hone down on something that's really level. Yeah, that's pretty good. You're also going to need to adjust the jumper for 16 or 32-bit motors depending on which you're using for your build. Make sure you do this while the power's turned off. All right, now that we have our hotbed installed and all the electronics tested, it's time to do the auto calibration routines. I'm gonna flip over our gecko plate just so in case we have any errors or crash down into it, we're not gonna mess up the special coating on the one side. So connect the prowler face if you aren't already, and then we're gonna mostly be sending G code to the machine. So we're gonna start off, you can send a G28 to home it, and then what we want to do is manually bring the Z-axis down so the tip of that probe is just basically barely touching the build plate. And I'm going to use the 10mm steps here. Right about there. When you get close, you might want to start using the 1mm steps just so you don't crash into the bed. But that's pretty good. Next, I'm going to save this as the 0 point by sending an M306 space Z0 command. This is going to tell the printer that this is the 0 point off the bed. This is just sort of an approximate ballpark range, so the auto calibration routine kind of knows where to start measuring. Great. Now that that's been entered, we're going to enter M500, and this saves that setting to the disk. And I'm going to bring it back up to the top with G28. And we can test that it knows where to go by typing in G1 space Z0. This will tell the printer to go down to the 0 point that we just set. Yep, right about there. So that's good. So we can home it back up with G28. All right, now it's time to do the auto calibration routine. You have your Z probe attached and connected to the board, and I'm going to enter the code G32. This is going to initiate a procedure where the printer goes around using the probe and measures various points across the build plate to determine the height. This can take a while. All right, it's complete. Now I'm going to enter the code M500 once again to save all these settings. And I am going to send it home with G28. And we can try G1 Z0 again just to make sure it still knows where the 0 point is. Yeah, good. Home it back. Okay, now we need to do the auto leveling routine, and that's very similar. The code is G31. Well, looks like it's completed. I'm going to save this again with the M500 command. And the settings are saved, and I'm going to send it home with G28. Now I'll just try, for reassurance, I'll try G1Z0 again, just to confirm that it still is on the mark with 0. That looks pretty good. Okay, we can send it home. All right, that completes all the auto calibration stuff. We can go ahead and take off the Z probe and disconnect it. We're not going to need it anymore right now. What we're going to do next is called the paper test, where we actually bring the hot end tip down and fine-tune the Z height calibration. All right, I'm going to remove the Z probe now that everything's calibrated, and we can get ready to do the paper test. Again, remember to be really careful with the wires coming out of the heating element. They're pretty fragile. We can set this aside. You might want to save it for future use, but we're not going to need it anymore. Okay. Now what we're going to do is we're going to lower the nozzle down manually until it's just barely touching the paper. You're going to want to use copy paper that's maybe slightly thicker than like the standard stuff, or what we're going to use, we're using thinner paper, so we're going to bring the nozzle down so it's tight and then back off like 1/100th of a, or 1/10th of a millimeter. So I'm going to enter the G1Z0 command, and that's going to take the effector plate down to where it thinks 0 is when it had the end stop probe on, right about there. Now, from this position, we can manually creep down. Be careful with going at 10 millimeters per step at this distance. So I'm getting really close. I'm going to switch to the 10th of a millimeter. Right about there is pretty snug. I'm going to back off just one step so the paper, yeah, the paper catches. It's a little friction, but not much. All right, I brought it down, and the paper is just grabbed just lightly by the tip there. So I'm going to send the command I'm going to send the command M306Z0. And what this is going to do is reestablish this as the new 0 point. And it says it will take effect with the next home. So I'm going to send it home. And then I'm going to send an M500 command to save that. And all the settings should be saved now. And I can test this with G1 space Z0. And ideally, I'm going to put my hand here just in case, but it should stop just as it grabs the paper. And that's it. We're going to load all the calibration settings with M501. This loads all the config files that were determined doing our auto leveling and auto calibration routine. And that should do it. I'm going to just test it out once more with G1Z0. So now it knows, the height and everything is all calibrated, and it knows exactly the distance to the build plate to start extruding for a perfect print. All right, now that the Z-axis is calibrated, we're going to do a calibration print. I've gone ahead and preheated the bed and heater and using prounder face. I have the tip set to 230 and the bed set to 60. And I've loaded up filament into the extruder and fed it through. And I've done a little bit of a test. So I have like a filament extruding. I'm gonna leave the build plate turned upside down so it's the uncovered side is up and there's no chance of gouging into that special surface if something goes wrong. So if you remember, we loaded up the G-code calibration 230 onto the SD card when we prepared it earlier. So that file should be on here. And if you go back and to watch, you'll get the display screen so you can watch the temperatures rising and the little displays showing you which elements are working. So the T is the hot end temperature, and the first number is the current temperature, and the second one is the target. B is the bed, and it's the same thing. So it looks like we're to temperature. So I'm going to go into play and select the SD card, and then your G code should be here. We're going to do calibration 320 or 230. So what this does, it's going to do a number of concentric circles around the edge of the build plate.